In this lesson, we're going to evaluate composite functions given a table of values, just as you see right here, or a set of ordered pairs. And so let's look at number one. So number one, you're asked, or you're told, given the table of values that you see here, and so notice in the first column are the x values, the domain, and then f of x, these are the values, and then g of x, these are the values. So just remember what this means. So in order to do these problems, you got to know what this means. This means that f of, remember x is 1 here, so that means that f of 1 is 6, g of 1 is 3. F of 2, see this x? So when x is 2, this means f of 2 is 8, g of 2 is 5. So that's how you read this. It's important you read it correctly. F of 3 is 3, g of 3 is 2. F of 4 is 1, g of 4 is 7. So you see this is your x. So whenever x is 1, f of 1 is 6. Whenever x is 1, g of 1, see in place of x, substitute 1, g of 1 is 3, and so on. Okay? And these problems are extremely easy to deal with. So let's look at the first one, letter A. So I'm going to go ahead and rewrite it right here. So we want to find f of g of 3. So remember when you're dealing with compositions, composite functions, you always do the inside first. All right, so we got to find, so the first thing we got to do is we have to find g of 3. That's what we have to find first. Okay, so going to the table, I want to find g of 3, right? So I got to find where x is 3. So x is 3 here. So g of 3 is 2. So g of 3 is 2. So that becomes 2 here. Okay? So first thing I found is g of 3. So g of x, when x is 3, see this means x is 3 right here. So when x is 3, the value of g is 2. Okay? So that's what this says. Now, once you find that, then the next thing you're going to do is you're going to substitute in place of g of 3, you're going to substitute 2. So this becomes f of 2, because remember, g of 3 is now 2. So now we go back to the table. So this time x is 2. So f of 2 is what I want to find here. So you see now you're looking at your function f. So you got to use this column right here. So f of 2, so when x is 2, f of 2 is 8. Right? And so therefore your answer, you're going to say f of g of 3 is equal to 8. And that's the answer. Okay? Not difficult at all. It's a very simple process. All right, so let's look at the next one, B. So in B, we have g composed. Remember, the open circle means composed, so you're composing two functions together, f and g, and you want to evaluate it at the value of x to be 3. By definition, remember you have to use your definition, so by definition, this means g of f of 3. So it looks just like this now, except the inside function is not g, but in this case it's f. All right, so let's talk about what this is right here. So first of all, I got to find the inside function, the inside value. So I got to find f of 3 first. So let's go to our table. So remember, I got to go to my function f. So here's your function f right here. All right, so these are the values of your function f. Now, you're asked when x is 3, so you got to find x is 3. When x is 3, f of 3 is 3. All right, so this equals 3. Make sure you understand that this 3 is not the same as this 3. All right, so again, let's look at this. So I'm going to put it right here. So so remember, this is your x value. So x is 3 right here, right? This is what we're looking at. This is x equals 3 right here. Okay? So I want to find f of 3. So when x is 3, f of 3 is this 3 right here. All right, so that right here is this right here. Okay. Now, once you find that, now remember, f of 3 is 3, right? So now what we have is this. We have this equals g of 3 now. So now I'm going to do this. I'm going to go to my table again. And this time, since I want to find g of 3, I got to use my column g of x. So g of 3, so when x is 3, g of 3 is 2 right here. All right, so g of 3 is 2. So this becomes 2. So therefore the answer you're going to say g composed with f at 3 is equal to 2. All right, it is not a difficult process. It really is not. All right, so that was a table. So let's look at this one. Now this one, you're given a set of ordered pairs. So you could easily, well, in this case, you could have put in a table because the x values are not the same for all of them, but it's still a fairly easy process. So let's look at the first one. So remember what we do. So we got to find the inside first, right? So f of 1, I'm going to do that right here. F of negative 1, rather. F of negative 1, so I go to my function f, and whenever x is negative 1, this is what that says, x is negative 1, right? So here's x is negative 1. F of negative 1 is 3. So this becomes 3 right here. All right, so this becomes g of 3. Make sure you understand what we did. F of negative 1, so this is a set of ordered pairs for your function f and function g. So f consists of these ordered pairs, 1, 2, 3, 4, 5 of them. G consists of these ordered pairs, 1, 2, 3, 4. So to find the composition here at negative 1, I got to find the inside first. So I go to my function f. That's what that says I do. Go to my function f. So here's my function f right here. This says when x is negative 1, my y value is 3. So remember in a previous lesson you learned this. Let me go ahead and write it here. In a previous lesson, you learned this. So remember, f of negative 1, what that means? That means find y when x equals negative 1. That's what that means, right? So I go to my function f. I gotta look at the one where x is negative 1. So here's where x is negative 1, and it says what's the y value. So find y. So the y value is 3. All right, so f of negative 1 equals 3. Okay, so that's what I just said here. F of negative 1 equals 3. Now I've got to find g of 3. Okay, now this time to find g of 3, I use my function g. Now remember g of 3, what that means, this means find y when x equal 3. Okay, but I got to use my function g because that's my function that I'm looking at now. So g. So when x is 3, right here, that's the only one where x is 3, right? When x is 3, what's that y value? That y value is negative 8. So g of 3 is negative 8. So therefore the answer is going to be negative 8 right here. So the answer you're going to say g of f of negative 1 equals negative 8. All right, it's not a difficult process. It really is not. All right, let's look at B. Okay, so in B, you want to find f composed with g at 0. So first of all, since it's written in this way, you have to use your definition. So by definition, so you want to rewrite it like this. By definition, this means f of g of 0. So f is listed first, that's right here. G is listed second, that's going to be the inside function. That's a 0 right here. F of 0. All right, so remember we got to find this part first, right? So remember what that means, what g of 0 means. G of 0, remember what that means. All right, g of 0 means this, means what is y when x equals 0. Okay, but I got to go to my function g, so here's the one you got to go to. So when x is 0, this is the ordered pair where x is 0, and the question is, what's the y value? Well, the y value is 6. So g of 0 is equal to 6. Okay? Now, once you find g of 0, then that's now 6, right? So this becomes f of 6. That's what that becomes. So let's think about what that means. So that means, remember f of 6 means what is y when x equals 6. So, but you got to go to your function f now. So you got to go to this. So when f of 6, when x is 6, rather, this is the ordered pair where x is 6, right? So when x is 6, what's that y value? Well, that y value is 2. So f of 6 is 2. And so therefore, see, f of 6 is 2, right? So what you now found is this. You now found that f composed with g at 0, f composed with g at 0 is equal to, it's equal to 2. That's what you found. All right, so there's the answer. It's not difficult at all. So let's look at the next one. So the next one, so f composed with, f of g of 8, so that's how you read this, f of g of 8, that's a composition. So f of g of 8. So by definition, or I got to put an extra parentheses here. So I got to find g of 8 first, right? So let's talk about what g of 8 means. So g of 8 means this. Means what is y when x equal 8? But I got to go to my function g though. So my function g, let me go ahead and use this one. So my function g is this one. So when x is 8, so I got to find the ordered pair where x is 8. So there's where x is 8. So my y value is negative 1. So g of 8 equals negative 1. Okay? So that becomes, right here, that becomes negative 1. Y'all agree? G of 8 is negative 1. So now this is going to equal f of negative 1. So now let's talk about what f of negative 1 equals. So f of negative 1 means what is y when x equal negative 1? Oops, sorry. F of negative 1 means what is y when x is negative 1. But remember, this time you got to go to your function f, and you got to find the ordered pair where x is negative 1. Well, x is negative 1 here. What's that y value? That y value is 3. So f of negative 1 is 3. So therefore, what you found is this. So remember, f of negative 1 is 3, right? So what you found is that f of g of 8 is equal to 3. So your answer, f of g of 8 is equal to 3. All right, and then let's look at this one. So in this one, g composed with f at 4. So remember, the first thing you have to do is write out what it means to make it look like this right here, like in C. So you want to change the notation here. All right, so by definition, this means g of f of 4. Okay, and so g is listed first, f is listed second, f is listed inside this part here. So we got to find f of 4 first. All right, so f of 4, I'm going to go ahead and use this right here. So f of 4, so remember what that means. So we got to find f of 4, right? So I have to find f of 4. Remember what that means. That means I go to my function f, and I want to find, so what is y when x equal 4? That's what you're trying to determine. But you got to, since this is f, your function f, you got to use your ordered pairs that go with f. So when x is 4, here's the ordered pair where x is 4. So when x is 4, the y value is negative 3. So this becomes negative 3. So this right here is negative 3, right? So now you got to find g of negative 3. So this equals g of negative 3. So now, remember g of negative 3, so let's talk about that. So g of negative 3. So remember, g of negative 3, you're asking what is y when x equals negative 3 for the function g. So when I go to function g, the ordered pair where x is negative 3 is this one. So my y value is 7. So g of negative 3 is equal to 7. And so therefore, this right here becomes g of, this right here becomes 7, right? We'll take this away. That becomes 7. And so therefore, g composed with f at 4, so your answer, g composed with f at 4 is equal to 7. All right, and so that was number 2. It's not difficult at all. Not difficult at all, as long as you understand what all this means right here. All right. Okay, let's look at number 3. So in number 3, we have, let's see, we have this in number 3. So we have a table again. And when you do the Alta assignments, you'll see it's almost all tables when you get to that that part of the lesson. Okay, so there are two things you want to find. Now remember what this means. This means that when x is -1, f of -1 is 3. When x is -1, g of -1 is -2, and so on. Just like in the first problem that we did. All right, so notice the notation looks different here, but those are all compositions. All right, so you're dealing with composition of two functions. You're composing two functions. So let's look at part A. We're at part A here. So you want to find g of f of -1. So when it's written in that form, it's easy to determine what to do first. You're going to find f of -1 first, right? So you can find f of -1 first. All right, now when finding f of -1, so let's go ahead and think about that. When finding f of -1, got to find that first. Remember, you're going to go to your function f. So here's the function f column right here. Now this says what is y when x equals -1. So here's where x equals -1. See, x equals -1 here. So f of -1. So this is y. Remember, f of x is y, g of x is y. But since I'm dealing with the function f, I got to use this column. So what is y when x is -1? Well, when x is -1, f of -1 is 3. My y value is 3. So this is 3 right here. Okay? So what that means then, is that this, remember this is 3. So what that means now is I got to find g of 3 because f of -1 is 3. So the same process, right? So I go to my column G now because that's G. Go to my column G, and remember what this means. So always think about what that means. G of 3. So this is x right here. So when x is 3, what is y? What is the y value? What is the y value? Okay? So when x is 3, what's the y value? So when x is 3, here's where x is 3. So when x is 3, g of 3 is 6. So that's your g column right here. So that's 6. And so therefore the answer, you're going to say g of f of -1 is equal to 6. All right? And that's it. That's all you do. For B, same idea for B. It's not any different, except you have to use the definition because of the way the notation is here. So this means, remember, open circle means composition. So f composed with g at 0 means f of g of 0. Okay? And so just like you did in the previous problem, you're going to look at g of 0 first. So remember what g of 0 means. So g of 0 means when x, this is x here, x is 0. When x equals 0, what is the y value? That's what that means. All right, so g of 0. So let me go ahead and use this right here. Okay, so g of 0. So g of 0, you got to use your function g. So when x is 0, see x is 0, when x is 0, what is the y value for g of 0? So what is g of 0? So g of 0 is 8, right? G of 0 is 8. So that equals 8. Okay? So what I have so far is this. I have g of 0 is 8, so now I've got to find f of 8. I have to find f of 8. So remember, f of 8 means this. So let's think about what that means. Same information, same idea. F of 8 means, remember this is x here, f of 8 means when x equals 8, what is y? That's what that means. So this time, though, I got to use my function f. So here's your function f right here, that middle column. So when x is 8, that's where x is 8 here. And when x is 8, what's that y value in the f column? Well, the y value here is 5. So f of 8 is 5. So this equals 5. Okay, so what we found is this. We found f of 8 is 5, which means this equals this. So you answer, you're going to say f composed with g at 0 equals 5. Okay, so that was number 3. Okay, let's look at one more. So it'll be number 4. Now, number 4 has quite a few, but that's okay. We just need some practice here. Except this time it's written horizontally, and there's some negatives in there, but we can deal with that. All right, so let's take everything we've learned in the previous 3 problems and see if we can go through the analyzation of each of those. All right, so notice in some of the problems you have different notations. So this f composed with g at 1, this here is f of g of 2. All of those though mean the same thing, the idea of compositions. When you have that open circle, though, you got to use the definition. You got to rewrite it to where it looks like this, like the one in part B. So this means f of g of 1. All right. Now, just like we've been doing, we've got to find g of 1 first, right? So I got to go to my g row. So these are rows now. So g row. So when x is 1, remember this right here, x is 1. When x is 1, you got to find where x is 1. So x is 1 here. What's that y value? The y value for g is 0. So g of 1 is 0. So I'm going to find f of 0. So same thing. So now I'm going to go to my f row, my f function, and this time x is 0. So here's where x is 0, and the question is, what's f of 0? Well, f of 0 is 5. So this is 5. So therefore, the answer, you're going to say f composed with g at 1 is equal to 5. All right, it's not difficult. It's fairly simple to do. So let's go to the second one. So the second one is already in that nice form, so you just got to find g of 2 now. So remember, x is 2, right? So you got to find what is the y value for g when x is 2. So here's your g row. So you got to find where x is 2. So x is 2 here. So now, remember g. So therefore, g of 2 is negative 3. So it becomes f of negative 3. So now you're going to go and find what f of negative 3 is using your f function. So this time x is negative 3. So here's where x is negative 3. What's the y value? What's f of negative 3? F of negative 3 is 11. So this becomes 11. So your answer, you're going to say f composed with g at 2 is equal to 11. Very simple process, not difficult at all. Okay, so here, f composed with f at 3, so the functions are the same. So in this problem, you're not going to use g at all. See, there's no g here, so you're not going to use g at all. You're just going to use your function f. Okay, so by definition, remember this means f of 3. So we got to find f of 3 first. So when x is 3, remember this is x right here. When x is 3, what's that y value for your function f? So f of 3 is negative 1, right? F of 3 is negative 1. So this becomes f of negative 1. F of 3 is negative 1. Now to find this, I go to my function f again, and this time x is negative 1. So here's where x is negative 1. My y value is 7. F of negative 1 is 7. All right, and so therefore your answer, so this equals this. So f composed with f at 3 equals 7. All right, not difficult at all. It's a very simple process. Okay, so let's look at D. So I'm going to go ahead and put this one here. So at D, so let's talk about D. So again, you got to use the definition of composition. So this means G of f of 3. So I got to find f of 3 first. So I got to go to my function f. And remember, this is x. So when x is 3, what's f of 3? So here's where x is 3. X is 3 here. F, this is your f function, your f values, your function values. So f of 3 is negative 1. So this becomes g of negative 1. Now I've got to find what g of negative 1 is. So this time it says I go to my function g, and when x is negative 1, what's that y value? So when x is negative 1, g of negative 1 is 0. Okay, so that's 0. So therefore this equals this. So you answer. You're going to say G composed with F at 3 is equal to 0. All right, and then let's look at E. So E, same thing. You're going to use your definition of compositions of two functions. So we're using G's here, so we're not going to use F at all. So G, this right here means G of 1. That's a parentheses right here. So that's 1. So we got to find G of 1 first. All right, so this says when x is 1, what's my y value for g? So what's g of 1? So when x is 1, g of 1 is 0. So I'm going to find g of 0. So now I'm going to go, now x is 0. So when x is 0, g of 0 is 1, right? All right, so therefore g composed with g at 1 is equal to 1. So you answer, you're going to say g composed with g at 1 is equal to 1. All right. And then F, so F is already in that form that where it's G of F of negative 2. So F of negative 2, so remember this means F of negative 2 means when x is negative 2, what's the y value? What's F of negative 2? What will be that y value? So I'm going to use the F function first. So when x is negative 2, here's where x is negative 2. When x is negative 2, f of negative 2 is 9, right? So this becomes g of 9. So f of negative 2 is 9. Now I'm going to go to my function g, and when x is 9, I got to find out what g of 9 is. So here's where x is 9. G of 9 is negative 10. So it becomes negative 10. So therefore, this equals negative 10. So your answer, g of f of negative 2 is equal to negative 10. And that's it. So it's a very simple process. That's how that's the thought processes that you go through when evaluating functions given a table of values or a set of ordered pairs. It's not difficult at all. It's a very simple process to evaluate functions where tables are given or a set of ordered pairs are given. All right, so that's going to be the end of this lesson.